So this video is going to review a number of Algebra 1 concepts that are necessary to be successful in this unit. While I'm going through this virtual notebook, you will want to have your virtual notebook open and be writing down on your virtual notebook what I have written down on the screen. The first concept we're going to review is solving equations. So there's two-step, multi-step with parentheses, multi-step without parentheses, and variables on both sides. I'm just going to run through these examples so that you kind of have a reminder of how to do this. So for a two-step, I want to start with subtracting my 5. I always do the opposite of what I see, and I do whatever is away from the x. So I'm going to cancel out that 5. So I've got negative 2x equals 35. Then divide both sides by negative 2. I get x equals negative 35 fifths, or sorry, negative 35 halves, or I can go ahead and divide. So negative 35 divided by 2 is negative 17.5. If this were not an ending decimal, I would want to keep it as a fraction, which you can see in the upper left-hand corner what that fraction is. Since this is a decimal that ends, I can go ahead and write it as negative 17.5. In general, you'll want to keep fractions, but in this case, either one is acceptable. Let's look at multi-step with parentheses. So there's two different ways that I can start this. I can either divide both sides by negative 3, or I can distribute that negative 3, which is the route that I'm going to go because this number won't always be divisible by what's in front of the parentheses, so I don't prefer to do that method. Distribution, I will not be starting with a fraction. So I'm going to distribute that negative 3. So negative 3 times 7x is negative 21x. Negative 3 times negative 9 is positive 27. And nothing changed with that negative 225. Now I'm going to solve it just like I did the two-step because I have a two-step. So I'm going to subtract 27 from both sides. So I get negative 21x equals, and negative 225 minus 27 is negative 252. I am going to go ahead and divide both sides by negative 21. Cancel out. Negative 252 divided by negative 21. Let's see. Negative 252 divided by negative 21 is 12. So in this one, x equals 12. I would have gotten the same exact answer if I started with dividing by that negative 3, but again, I was just trying to be careful that I didn't have any fractions I had to deal with until the last possible moment. Now a multi-step without parentheses. First thing I want to do is combine any like terms. So I do have like terms. Let's go ahead and highlight those. So my negative 8 and my negative 5 are like terms. And then my x's are also like terms. So I can combine my negative 8 and my negative 5. That's going to give me negative 13. And then combine my 10x and my 2x is 12x. And nothing changed with that negative 73. I could spell out these two steps, so I did two steps here with combining the two sets of like terms. I could break those into two different steps, but it's not necessary. So now I've got a two-step again. I'm going to take care of that negative 13. So add it to both sides. So I have positive 12x equals, so negative 73 plus 13 gives me negative 60. I'm going to divide both sides by 12, and I get x equals negative 5. All right, so that is a multi-step without parentheses. And then finally, we're going to look at variables on both sides. First thing I'm going to do is distribute this negative 3. And I am going to break this into a number of steps so you can see what's happening at each step. So negative 3 times 5 is negative 15x. Negative 3 times negative 21 gives me positive 63. Nothing happened to anything else. Now I'm going to distribute again. Nothing's happening on this side. So 5 times x is 5x. 5 times negative 2 is negative 10. Now combining like terms again. So my 63 and my 7 are my only like terms. So nothing else is going to change. 63 plus 7 is 70. From here, there are 4 different ways that I can start this. I can add 15x to both sides. I can subtract 70 from both sides. I could subtract 5x from both sides, or I can add 10 to both sides. My brain defaults to just dealing with the first thing, so that's what I'm going to do. I'm going to deal with that first thing. I'm going to add 15x to both sides. So I have 70 equals 5x plus 15x is 20x. Minus 10, nothing happened there. Now, once I've done that, I've locked in how I'm going to finish solving this. So the way that I'm going to finish solving this is just add 10 to both sides because I have a 2-step equation now. 70 plus 10 is 80. Nothing happened to that 20x. Finally, divide both sides by 20, and I get 4 equals x. No matter at this step how I had started it, I will end up, if I've done things correctly, I will end up with the same answer. So that's a review of solving equations from kind of a basic one onto a much more complicated one. Next up, we're going to look at variation. This is just going to be a whole bunch of definitions, no examples to get through here. So first up, we're going to look at direct variation. So direct variation is a situation where I have y over x is a constant value k. I'm going to move this over here. And that doesn't look much like a y, does it? Y over x is a constant value k. The equation is y equals kx. X and y are positively related. And it is a linear graph. When you graph y equals kx, it is linear. So that's direct variation. Inverse variation is when you have x times y is a constant value. Same representation, still k. But the equation is y equals k over x instead of k times x. X and y are negatively related, and it is a non-linear graph. So those are the two different types of variation. You can kind of see the difference between them. So now let's look at the characteristics of proportional relationships, which are also called direct variation. So characteristics of proportional relationships are continuous graphs of proportional relationships are linear and contain the point 0, 0. The ratio that we talked about above, that y over x, is a constant in the proportional relationship and is also called the constant of proportionality. Not particularly inventive, but it describes what it is. Proportional relationships can be described by a function of the form y equals kx, which we saw above. This is called a direct variation function. Now, a specific type of a proportional relationship are in this form y equals mx. So the graph of a function in the y equals mx family is a line that passes through the origin, which is 0, 0. The steepness and incline or decline of each of these values is controlled by the value m, which is the slope of the line. And these are those direct variation functions. So that's some information about variation. You're mostly going to be working with that direct variation, which is why it's a little bit more detailed, but just know that inverse variation is a thing. All right, next up are some specifics about equations. So we have rate of change or slope and our slope-intercept form. So the rate of change is a ratio that compares the change in the dependent variable to change in the independent variable. The rate of change is also called the slope of the linear function that models a linear relationship. The slope of the line is equal to this triangle here as a delta, if you remember from science classes. So it's delta y over delta x. So what that means, delta means change. So it's the change in y over the change in x. So the slope is the ratio of the change in the output variable y for a given change in the input variable x. Next is slope-intercept form, and when you kind of think about algebra, this is one of the major things that you think of. So the y-intercept is the point where the graph of the function intersects the y-axis, which happens when x equals 0. The y-intercept's coordinates are 0, y. The slope-intercept form of a linear equation is, this is what you will always see, y equals mx plus b, where m is the slope of the line and b is the y-intercept of the line. So again, kind of a classic one. Okay, trend lines. So there are two different methods to draw trend lines by hand. The first method is you're going to pick a point on that appears to lie, that should say lie, not line, in the middle of the points displayed in your scatter plot. That point doesn't have to be a data point. Using this point as one point on your line, you're going to adjust the slope of your line until you find the line that you think best describes the pattern of the data, and then find the equation of that line. So I am going to go with this point here. This seems like it's pretty much in the middle of my data. From that point, I'm going to draw a line that I think is in the middle of most of that data. Everyone's hand-drawn trend lines are going to be different because you're eyeballing this. So in Notability, you have the ability to draw a very straight line by dragging and holding. So I am going to start my line like that, and then you can see if I hold it, I can move it around. I don't want to move off of that center point. Well, I guess I could. That one, that looks pretty close to approximating things. So let's go with that. So that's my trend line. Now I'm going to find the equation of that trend line. Now keep in mind that my basic line is y equals mx plus b. M is that slope. B is my y-intercept. Y-intercept here looks like it's right at 4, positive 4. Now, my slope. This is where I'm going to do that rise over run thing that you've probably heard a lot about. So I'm going to pick 2 points that I can definitely see that they lie on 2 corners, pretty much. I'm going to draw a triangle connecting those 2 points, perfectly horizontal and perfectly linear, or vertical. Then I'm just going to count what my rise is and what my run is. On this particular graph, it is a 1-to-1. So each of these lines is 1. So this is going to be a positive 2. And then same thing here. These are all 1-to-1s. Scale is just 1. So this is going to be another positive 2. So my rise over run would be positive 2 over positive 2, which just simplifies to 1. So my final equation here is going to be y equals 1x plus that 4. Now, when you sketch out your trend line, it will probably look different than my trend line, and this equation will change based on however it is that you drew your line. I had done this previously and I got a completely different equation because of eyeballing that trend line. We're going to see in this unit how you cannot eyeball it so that you don't get that wide variation, but these are 2 ways to estimate trend lines. So that's the first one. The second one is that you're going to draw 2 lines in such a way that the points on your scatter plot are squeezed as tightly as possible between those lines. Those lines do not have to be parallel. Then you're going to draw a line halfway between the 2 lines that you've drawn and find the equation of that line. This data is exactly the same. we're going to see exactly how much of a variation you can get of those equations based on how you draw your trend lines. So I'm going to do this in a different color. Let's actually highlight. So my first line that I'm going to draw is on this upper bound, and I'm going to say that it's about there. That contains all of my upper data. Then I'm going to draw a line on the bottom about there. That contains my lower data, so I've squeezed it in real tight there. Now I'm going to draw the trend line, and I like to try to estimate this as close as possible between these two lines and go where this intersection point is. Okay, so I'm going to start from this intersection point at the bottom here. Try to draw a line that goes right through the middle. So you can see how different these two trend lines are even before I start writing the equation. Which method do I prefer? I kind of like the second method because I can just real easily pick out what's between my upper bound of data and my lower bound. But it's personal preference on this particular part. So now I'm going to identify my y-intercept, which looks like it's about at +1. Then I'm going to pick out, so this point lies directly at a corner and this point lies directly at a corner. All right, so I have +4 here, and 1, 2, 3, 4, +5 here. So rise over run would be +5 over +4. This does not simplify to a whole number, so I am going to leave it as a fraction. Whenever I'm dealing with slope, leave it as a fraction, because if you have to go back and graph it, it is way easier to graph rise over run than it is to try to estimate, like, okay, what's 1.2? So even if it's a nice number, when you divide it, leave it as a fraction. So my equation here is going to be my slope, 5/4 x, and my y-intercept is +1. So you can see how different those slopes are, how different those y-intercepts are. And again, depending on exactly how you eyeball your lines on here, your equations are probably going to be different than my equations. So that's how to estimate trend lines. Finally, we're going to look at measures of center. So measures of center is a fancy way of saying that mean, median, mode that you've probably done lots of times before. So mean is the average value. Here's how to calculate the mean. It is the sum of all of your observations divided by the number of all of your observations. So add up all of the numbers that you have, divide by how many numbers you have. The median is the middle value. You're going to arrange the data in order from smallest to largest. Then you'll start on both sides of the data and count into the middle number. If the number of data is odd, the median is the middle number. If the number of data is even, the median is the average of the two middle numbers. So you would add those two middle numbers and divide by 2. The mode is the most frequent data point in the data set. Oftentimes there is no mode, so you would just write none. It's not 0 because 0 didn't come up the most number of times. It is just that there is no mode. An outlier is a datum, which is the fancy way of saying a single data point. It is an outlier if it is well outside the general pattern of the rest of the data. More generally, an outlier appears to be outside the general pattern of the remaining data. So we're going to look at this data as an example. We're going to find our mean, median, and mode. So first up, we're going to add up all of our data to find our mean. So 13 plus 15 plus 14 plus 12 plus 15 plus 17 plus 13 plus 10 plus 15 plus 18. When you add all of those up, you get 142. Then I'm going to divide by how many of those I have. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 data points. So I'm going to divide 142 by 10. 142 divided by 10 is 14.2. When you're dealing with mean, median, mode, decimals are fine. You don't have to worry about using fractions for the most part. So our mean is 14.2. Now for our median. I need to put the data in order from least to greatest and then find the middle. So my first number is going to be 12. No, 10. 10 is the least number. Okay, I'm going to cross these out as we go. So 10, then it looks like 12 is next. Then I've got a 13. I've got another 13. No more 13s. So next looks like it's 14. No more 14s. Next 15. I've got another 15. And another 15. No 16s. Next would be 17. And I'm running out of room here, so I am going to lasso this. There we go. Okay. Move that so that I can get that 18 on there. Okay, so that's all of my data. Now I'm going to count in from both sides. So I just like to mark them off as I'm going. So 1, 2, 3, 4, and this is a situation where I have 2 in the middle. So I am going to add those. So 14 plus 15 is 29. Divide it by 2, and I get 14.5. So that is my median, my second measure of center. Finally, my mode. My mode is the one that shows up the most. And the nice thing when you have done median about the mode is that it's pretty easy to take a look at the data and see which one occurs most often. In this case, it looks like it's 15 here. There's 3 15s. So my mode is 15. As far as outliers go, it doesn't really look like there's anything that's massively more or massively less than what I have. There is a process that you can go through mathematically to find outliers. We're not going to worry about that. It's not particularly relevant to what we're doing. You just need to know how to find mean, median, and mode, and be aware that you could have these outliers that are significantly different than everything else. So that's a quick review of everything that you will need to be successful from Algebra 1 in this particular course. So now you're ready to make these predictions based on linear functions.